can all hear and see me? All right, so last class we did a lot of things with quadratics. We looked at solving quadratics a couple different ways. One when it was in standard form, one when it was in vertex form. We also looked at graphing quadratics in a couple different ways. We looked at graphing it in vertex form. We looked at graphing it in factored form. And today we're going to do a couple of different things. And the first off, early this morning, we're going to look at something not solving, but actually, well, it's kind of like solving because we're finding something out about the quadratics, and that is the maximum and the minimum values, the high spots and the low spots of our quadratics. All right, so and it ties into a lot of things we did the other day, or information we're going to need, or skills we're going to need from the other day. Now, so I have example 1 here. I have an equation which is in vertex form. All right, now I want to find the max or min values of it. Now, the thing is that when I have a graph or an equation, y equals x minus 3 squared minus 4, actually I could put a little secret one here. Now, I'm going to sketch this function. It's quadratic. And again, just a little bit of review of sketching a quadratic in vertex form is that first off, I got to find the vertex, hence why it's in vertex form. And it shifted right 3. So I'm just going to again do a sketch. There's 3 there, but down 4, -4. So my vertex would be right in here somewhere. Now it's whether does this parabola open up or down. And the key here is I look at my a value, which is the number in front of our brackets here. It's a 1. It's positive, which again means when we do our steps of 1a, 3a, 5a, the steps are going to be positive, and this parabola is going to open upwards. All right, so again, just a sketch. Now, here's what we're all about today is, again, about the max or the mins. And so what I really want to do today is fill in this sentence, is that there is a blank of blank when x equals blank. One sentence is going to tell me all the information that I want to know. Because what I really want to know is, when I'm dealing with max or mins, is do I have a max or a min? What is it? When does it happen? This sentence here fills in all the blanks. So in this particular example of my parabola, because it opens up, that means it has a low spot. So there is a min. How low does it go? Well, this parabola goes down to a height of -4. And when does it happen? The x value, that's what we're referring to here. Well, if we move over to 3, x equals 3, that is when we get our low spot. And so that one sentence there is a min of -4 when x equals 3, tells me that this quadratic function has a min, what it is, and when it happens. All right, so that sentence, again, is going to be key. Now, I wish it was that easy all the time here, but it's not. So now I move to my second example, where I have example 2. I have y equals x squared plus 8x plus 13. Now, this equation is in standard form. Bit of a problem because I don't know where the vertex is. So here's what we're going to do. We're going to do a process. Hopefully you learned in grade 10, but again, I have no idea what you learned in grade 10. We're going to complete the square, which is converting a quadratic equation from standard form to vertex form. And so essentially what we're looking at is taking something like this and making it look like this. Y equals a times x minus h squared plus k. All right, now, here's the thing. Here's how we do this. Now, it takes a couple of examples to kind of get the hang of it. Hopefully, I'm jogging your memory, but again, starting from the top. All right, now, here's what we do is, first off, I've got x squared plus 8x. All right, now I'm going to put that in brackets, and I'm going to leave a space there. Now, this 13, I haven't forgot about, so I'm going to put it over here at the end. Now, what I want to do is there is a pattern that somebody's figured out, all right, that can create the x minus h squared part, all right? There is a pattern. Now, here's how this pattern works, is that I have to look at the x term number. So in this case, the 8x term. And what I do is I take that 8, I have to cut it in half. So I get a 4. And then I have to square it. So you take that number in front of the x, you cut it in half, and then you square it. And I get a 16. All right, so that is the number that I need in this space right here to complete the square, to create a pattern. And I'll show you how that works. Again, it takes a little bit of time. So I'm going to put that plus 16 right here because that is what we call the correct constant term. That's the number I need. Now, here's the thing in math. I can't just throw a 16 in there. All right, that changes the equation. I don't want to do that. So I'm going to balance the equation out by not only putting a plus 16 in, but I'm putting in minus 16 afterwards. That way, the net effect on this equation is nothing. I put 16 in, I took 16 out. Means I didn't change it. I did change the way it looks. All right, now, here's the thing now. What I've done is called completing the square. I've got the right pattern because someone has noticed is that if I take half of this number and I square it and it's right there, I can rewrite that 8 or that x squared plus 8x plus 16. I can rewrite it and make it look differently. And here's how it's going to look different. I'm going to put an x here. And then I have to do half of that number in front of x. So half of 8, which is a positive 4. And there we go. So these two are what's called equivalent. They're the same, but they look different. So if I was to take x plus 4 times x plus 4, which again we did earlier in the unit 1 FOIL, and I multiplied it all out and collected like terms, I would get x squared plus 8x plus 16. Somebody noticed that. Who knows? I don't know who. All right, now we've got that part, but I still have this leftover numbers. Okay, on the side here, this minus 16 plus 13. I put them together, lose 16, gain 13 back. I'm at minus 3. All right. If you look, this thing is now in vertex form. And so now I can complete my sentence where I have therefore, and again, I'm going to do my sentence here. All right. So I'm going to look at there is a blank when x equals blank. And here it is. I'm going to fill in the blanks. All right. So once again, if I want to know if this is our max or min, now I'm not going to draw a graph this time. There's a 1 there again in front. That's our a value. Because it's positive, just like our first example here, it means our parabola opens up. So that means, again, we have a min. Now, how low is that min? Or how high is that min? I guess how low that min is, really. Well, we look at our y number, our horizontal our vertical displacement, which is our k value at the end. This graph is being shifted. The vertex is being down 3. And again, the vertex is where you have a max or min. All right, so that means that the min is negative 3. When does it happen? We look inside the brackets here for our x value. And again, this is the trick here again. It always looks the opposite, right? Because there's supposed to be a minus sign there, but there isn't. And so that means it's when x equals negative 4. Just like in our first example, I had a minus 3. Well, actually, your x value is 3 because there's supposed to be a minus sign in the equation. All right, so again, I hope I'm jogging a bit of a memory here. But again, we're going to do a few examples. So my next one. So we get example number 3 here. Let's see. All right, so example number 3 says, what equation do we have here? We have y equals 3x squared minus 12x plus 24. All right. Now this one's a little bit different, a little harder. It's another step up, but we are going to complete the square. We are going to make it look in the form y equals a times x minus h squared plus k. All right, we're going to make it look like that. Now here's the problem. Here's the difference from the last one. There is a 3 in front of our x squared. That changes things. And so what I'm going to do first to this equation is I'm going to factor out the 3. I'm going to take a 3 out of every single term, all right? So I got a 3 out front. I'm factoring here. And so, well, and which that means, again, is that if I'm pulling a 3 out of every term, I'm dividing every single term by 3. So 3 divided by 3 is 1. So I got that x squared, because that's what I need there to complete the square. Negative 12x divided by 3, that's a minus 4x. And 24 divided by 3 is a positive 8. All right, so now I have a quadratic inside my square brackets where there's a 1 in front of the x squared. And again, that's what you need to be able to complete the square. All right, so now I'm going to rewrite it because I'm going to complete the square here. Again, completing the square is all about just putting the right number in so that you complete the pattern. All right, so it's going to look like this right now. All right, so I put my x squared minus 4x part in brackets. 8 is not the number I want there. And here's again how I find the number that completes the square or fixes the pattern. I look at the number in front of x. And this time it is a minus 4. So again, I have to cut it in half, minus 2, and square minus 2. And minus 2 is 4. And so to complete the pattern, I need a positive 4 here. But again, I can't just throw in a 4. I have to balance it out. So on the outside of that round bracket, I got a minus 4. All right. So now the pattern has been completed. So in brackets here, I'm going to have a squared, right? Binomial squared there. I have an x here. Now, the number that goes right here is half of the number in front of your x value. Well, half of negative 4 is negative 2. It goes right there. All right, so if I did FOIL, x minus 2 times x minus 2, this is what I would get. So again, just rewriting it, making it look different. All right, then I got these leftover numbers, right? I got a minus 4 plus an 8. That's a positive 4. All right, now here's the thing, is I've now completed the square. Remember, I took the 3 out to do that. So now that I've completed the square, I'm going to put the 3 back in. So to do that, I got a 3 outside these square brackets. I'm just going to do the rainbow rule. I'm going to go 3 times that big term. So I've got 3 times that big term, and I'm just going to write it out like that. All right, and then I still have to do 3 times the 4. All right, so 3 times the 4 is a 12. All right, so now I have it in vertex form. I have my y equals a x minus h squared plus the k. So now I can complete my sentence. There is a blank of blank when x equals blank. All right, so I check it out. Let's see here. My a value, again, will tell you whether I have a max or a min. And, well, just I'm not changing it up here yet. But the a value is positive, which means, again, our steps are positive. This is going to be a parabola that opens up. So, again, it's a min. And again, here's my vertical number. All right, so it's being shifted up 12, this vertex, and so it has a minimum of 12 when x is equal to 2. There we go. So I've taken this quadratic in standard form, converted it to vertex form so that I know where the vertex is, which is, again, always the spot where you have the max or min. And then I can state whether I have a max or min, what it is, and when it happens. All right, got one more of those. Let's see here. All right, so the next one, word problem. I have a word problem in math. Example 4, so I'm not going to write it all out, but we'll get to the nitty gritty here. My flying squirrel is given by the equation h is equal to negative 0.5 x squared, all right, plus 6x minus 11. All right, where x is time in seconds and h is height in meters. I always have that. Find the maximum height of the squirrel and the time it occurs. All right, so again, I have a quadratic equation that is in standard form, right? Ax squared plus bx plus c. All right, and I need to complete the square to get it in vertex form. Now, again, I can't do that just yet because I have this negative 0.5 in front of my x squared. I can only have a 1 in front of my x squared to complete the square. So once again, I am going to factor out a negative 0.5, which again means divide every single number, or every single term, I should say, by negative 0.5. And so if I take, negative 0.5 divided by negative 0.5, it's a 1. Hence why I'm doing it. I got my 1x squared. I take 6 and divide it by negative 0.5. I actually get a negative 12. So I'm going to have a negative 12x. And then if I take negative 11 and divide it by negative 0.5, negative divided by negative is going to be a positive, and it's going to be a positive 22. All right, so again, inside those square brackets, I have a 1 in front of the x squared, so now I can complete the square, which means find the correct number that gives me the pattern so I can rewrite it. All right, so now I have h equals negative 0.5 x squared minus 12x. So again, I'm going to put that in round brackets. The 22 is not the number I'm going to be looking for. Be nice if it was, but it's not. So I'm going to put it over here, plus 22. Now, what is the number that needs to go there? Could somebody help me out? If you know what I'm doing here. What number is the correct number that will help me complete this pattern? Complete the square, if you will.
6.
Not quite. Remember, I look at the number in front of the x, I got to cut it in half and square it.
Negative 6.
That's cutting it in half, and then you square negative 6. What do you got?
Is it 36?
36. Yeah, negative 6 squared is 36. So again, I put a plus 36 there. Can't just do that. Got to balance it out. Minus 36 over here. All right, so now I can rewrite this. So I got h equals negative 0.5. I can now rewrite it because I have the correct number there. Again, there's going to be an x in here. That's the form. Somebody tell me what number will go inside my round brackets. What do you think? What goes inside those round brackets?
6.
Close. Gotta watch your sign. In front of that 12 is a minus sign, so it's going to be a minus 6. All right, and then what do we got going on over here? The leftover stuff, minus 36 plus 22. I believe we're down 14. All right, so I completed the square. So now what I have to do is do the rainbow rule and put the negative 0.5 back. All right, so I'm going to multiply. All right, so I have h equals negative 0.5 times that big thing. Well, I'm just going to leave it at that. Negative 0.5 times that big thing. All right, so there's one part done, and then negative 0.5 times negative 14. Negative times negative is going to give us a positive, and I believe it's a positive 7. All right, so now it's in vertex form. Y equals a times x minus h squared plus k. All right, so then I can answer my question. What's this saying? This is a word problem, so it's got some meaning here. All right. I do know that it's a maximum. Look at my A value. So the squirrel reaches a maximum height. And again, I would know it's a maximum height because my A value is negative. That means my steps are downwards, so our parabola is an upside down U. Height of, can somebody tell me what the maximum height is? Got a bunch of numbers in there. Easy to answer if you can find, if you know what I'm looking for. Impossible if you don't.
7.
7, yeah, 7 meters. When our time, again, inside the brackets, because X is our time, or 7 meters, I should say, after 6 seconds. All right, so it must be suspended in midair, kind of like the Matrix, I guess, for the squirrel. All right, so there. Now that's completing the square, finding maximum ends of completing the square. But we're going to do it another way, part 2. All right, and let's see here. So that's converting it to vertex form. I'm going to do it a different way. We're looking at 2 different ways. And this relates to something we did earlier this unit, or last day, I should say. All right, so I get to example 5. Again, if you're looking at my note, posted. We're looking at the equation y equals negative 2x squared plus 4x plus 16. All right, so again, it is in standard form. We're not going to complete the square this time. What I'm going to use is my x-intercepts to find the vertex. Now, we did this when we were graphing in factored form. So the first thing I'm going to do is factor this thing, all right? Because then I can find my x-intercepts, which then, because the parabola is symmetric, I can find my vertex, and then I will know my max or min value. Now, the first thing is my A value, when I look at this equation, is negative 2. And because it's negative, I know that this equation opens down, or this parabola opens down, and so I have a max value. I can tell you that just by looking at the equation, because of the A value in standard form is the same as the A value in vertex form. All right, but again, I want to solve this or find the max or min using my x-intercepts, which means I need to factor this thing, which I know a lot of you just love. All right, so when I factor this, I'm going to have it in 2 pieces here, right? All right, so I'm going to go over here, and again, I got to do my chart. Make sure I get them out of the way here. All right, so again, in the top left corner, I have a negative 2x squared. And in the top right corner, I have a 16. Ooh, lots of multiples here. This could be a tough one. All right, so again, when I do the crisscross and I add them, I get a 4x. All right, let's see what we got here. So I'm going to go with negative 2x and a 1x, I guess. And let's try an 8 and a 2. All right, come on. Let's see if I got it right here. All right, so when I cross multiply, I got 8 times x, which is 8x. Minus 4x's. Bingo. That is a total of 4x. All right, so I'm going to write my factors in here. So I go across horizontally. So I got negative 2x plus 8. And x plus 2 would be my other factor. All right, now, again, I'm going to set each of these pieces equal to 0 because that will find my x-intercepts. All right, so let's see what we get here. Solving the first piece, move the 8 over. I get a negative 8. Divide by my numerical coefficient. I get x equals 4. So that is one of my x-intercepts. All right, the other one, I get x equals, I just bring the 2 over, and I get negative 2. All right, So there's my 2x-intercept. Now, again, as we graphed in factored form, the vertex is in the middle of these two guys. It's in the middle. So to find the vertex, I'm going, of the x coordinate anyways, all right, I'm going to find the middle or the average. And so I take my 4 plus my -2. And because I got two numbers, I'm taking the average of it. I divide by 2. And let's see here. So my x value is, let's see here, 4 plus -2 is 2 divided by 2, 1. So there's the x value of my vertex. But again, just like we did when we were graphing, I'm going to sub x equals 1 into the equation to find my y. All right, so we got y equals -2, and then it's x squared, so it's going to be 1 squared, plus 4 times 1. Again, just using my equation up here, plus 16. All right, and then I get y equals, let's see here. 1 squared is 1 times -2 is -2. 4 times 1 is 4 plus 16. All right, let's see here. Add those numbers up. Well, -2 plus 4 is 2. Add 16, we get 18 total. All right, so now I know the vertex is at 118. So now I can finish that sentence. It tells me everything I need to know. So therefore, there is a blank of blank when x equals blank. Again, at the very start, my a value was negative, which means my steps are negative. This is an upside down parabola. So now I have a max of, and again, it's my vertical number, the y value, which is 18, when my x value is 1. There we go. All right, we'll do one more of those. Example number 6. So again, this is just like when we were graphing using factored form. Same idea, different ending. All right, so we got example number 6. And our graph this time is y equals, or parabola, y equals 2x squared plus 4x minus 30. All right, so again, look at my a value. It's positive. And because it's positive, that means our steps are positive. Our parabola opens up. Already, I know I got them in. Okay, now you're going to find out where that mean is and what it is. All right, so now I'm going to factor my equation. All right, so again, go over here for my factoring table where I have my first term, 2x squared, on the top left. I got minus 30 in my top right. All right, so I'm going to go with 2x and x on the one side and two numbers. So I'm going to have to cross multiply here and get positive 4x again. All right, yeah. Let's see, 30. What about 6 and -5? Let's see, I get 12x minus 5x. That's 7x. Not this time. All right. Let's see here. Let's go with 15 and 2. -2, I guess. So I get 15x minus 4x. 11x. Nope. Uh-oh. All right. What else we got here? It gives me 30. 10 and 3, right? 10 and -3, I guess I got to go with. All right. So I got 10 times x, 10x minus 6x. That gives us the 4x. Good. All right. So I got 1 here. Factor is 2x plus 10. And then the other one's x minus 3. All right, I solved both pieces to find my x-intercepts. All right, so here I bring the 10 over. We got a minus 10. Divide both sides by the numerical coefficient, and one number here is I get negative 5. All right, bring the negative 3 over to the other side. That one's not bad. That's, yeah, a 3. All right, so there's my two x-intercepts. The vertex is going to be in the middle of those two, so I can find the x-coordinate by finding what's in the middle, or the average of the two. So I have a negative 5 plus a 3 divided by 2. What do we get? Negative 5 plus 3 is negative 2 divided by 2. That's a negative 1 this time. All right. And so now I'm going to find the y-coordinate of my vertex by subbing in x equals negative 1. All right, so now I've got y equals 2, and let's see, x squared, so negative 1 squared, plus 4 times x, so plus 4 times negative 1, minus 30. All right, so what do we got here? Let's see. Just simplifying using Bedmas. Got to do the exponent first here. Well, negative 1 times negative 1 is a positive 1 times 2 is 2. Then minus the 4. And then minus the 30. Okay. 2 minus 4 is minus 2. Minus 30 is minus 32. So this time my vertex is actually at negative 1, negative 32. But either way, I can now complete my sentence. There is a blank, a blank, when x equals blank. All right. And again, do we have a max or a min? We have a min because our a value is positive, which means this parabola opens up. What is the y value? The height of it, or lack of height in this case, a minus 32. And when does it happen? What is our x value? It's negative 1. All right, so there's two different ways we just looked at finding the max or min values. Completing the square, which again, you're supposed to have done in grade 10. A little bit of review, maybe, maybe not. This is a little bit new by finding the vertex using the x-intercepts, which again, we did when we graphed in factored form. But again, you got to be able to do the sentence either way. Finish it off by saying, if it is a max or min, how big it is or how small it is, and when does it happen?